Welcome everybody to our next chapter in trigonometry. What we're going to be talking about today is some applications of trig. We're talking about some basic applications. I mean, we have not learned nearly all of the material in trig. There's tons of more stuff to go through. But for what we're doing in this course, now we're getting to some real life applications. Now, what that means for you is that you need to know how to do trig to begin with. You need to know how to find angles and sides. So if you don't know how to do that, you need to go back to the videos for lessons 3, 4, and 5, because if not, you're not going to be able to do any of this stuff. Also, we're going to keep in mind a couple of things that we went through at school. One of them is the word problem procedure. Okay. How I do word problems is by answering a couple of quick questions. It's what, info, plan, and solve. So the what refers to what is the question asking us. We always want to know what questions to answer. Sometimes there's one question, sometimes there's two, or maybe even three questions in one word problem that we're trying to solve. Okay? The info is the info throughout the question that's necessary for us in order to solve it. Plan refers to, in pretty much all of geometry, of drawing some sort of picture. And because we're talking about trigonometry, we know we're going to have mostly right triangles to work with. So that's a nice easy thing to do for a plan. And solve means when we look at our plan, we look at the picture and we think about the right tools that we can use in order to solve it. Sometimes it's going to involve algebra, sometimes it's going to involve calculators and that type of stuff. So with trigonometry, you can probably bet that we're going to need to be using both algebra, trig, and the calculators all in the one problem. So let's go through this problem. We're going to identify first the what. All right, so it tells us here a building is casting a 53-foot shadow with the sun at an angle of elevation of 32 degrees. How tall is the building to the nearest foot? So the what here, what they're asking us is how tall is the building to the nearest foot. This is important right here, nearest foot. It's telling us exactly how many decimals, if any, we need to have in our solution. This particular solution, we don't want to have any decimals. We want it to be a whole number. The next thing we do is we look through the problem for info that's necessary. Now, sometimes application problems, word problems, they're going to throw in extra stuff to try to throw you off. Or sometimes they don't even throw in extra stuff to throw you off, they just give you background information. So we need to filter through and find the stuff that's really important to us. Okay, so here it says the building is casting a 53-foot shadow. Well, that piece of information, including the part about a shadow, is important because we know where shadows are. They're on the ground, and we know a length of that shadow. Okay. The next thing it tells us is that with the sun is at an angle of elevation of 32 degrees. Well, angle of elevation just means that if you were standing on the ground and looking up towards the sun, that's the angle of elevation. You're looking up towards the sun. So the next thing we want to do is make our plan. And again, our plan is always going to consist of some sort of picture. So here we're talking about a building. Okay, here's our building. And it tells us that it's casting a 53-foot shadow. So here's the shadow. It's 53 feet long. And as you remember a minute ago, we said that the sun is what's causing this shadow. And it's at an angle of elevation. Angle of elevation means looking up towards the sun. So we're looking up this way, of 32 degrees. What we're trying to figure out is how tall the building is. So we're going to place our X at how tall the building is. Now, you should at this point already know how to label and how to solve all of these problems, right? We have a right triangle. We can mark our theta. We can mark the sides they gave us. We figure out using the sides O and A, we want to use tangent. Tangent of 32 equals x over 53. And now we solve. Solving for x here means multiplying by 53 first, x equals 53 times tangent of 32 degrees. We need to now go to our calculators. Again, I don't have a calculator here to put on screen, so I'm going to tell you right now, if you want to know how to do this with the calculators at school, you need to come in, ask some questions. If you're not sure already, I can help you out with that. If you're using an iPhone, it's trickier with an iPhone, I'm going to be honest, because it's a little bit backwards with the programming from what we're used to typing in. Again, if you are planning on using your iPhones, let me know in class. I can show you how to use them. And lastly, what I'm going to be using is Google. When you go to Google and type in calculators, it's going to give you one that works with trigonometry. Just please remember, we're working in degrees, so you're going to see a little toggle switch right now. When you first sign on to the Google calculator, it says RAD. You hit the little toggle switch and it will move over and it will reveal DEG, which stands for degrees, which is what we're working in, degrees. So we want to make sure it's set to the right function. Okay, so I'm going to go to the Google calculator. I'm going to type in 53 times tangent of 32, hit enter, and it's going to give us our solution of 33.1. But our instructions, or the what of this question, says to the nearest foot, so I know that 0.1 rounds to just 33 feet. What we need to keep in mind here, though, is that application problems, or word problems in general, we want to definitely make sure that we answer the question the same way that it's being proposed to us. So they ask us written with the sentences, so we want to respond with written sentences. Now, we don't need to go crazy with this. We can just write a quick solution out. It's asking how tall is a building, so we could just simply say the building is. Here it's 33 feet tall. That's enough of a written response for me. Okay, I don't need a diary about your discoveries. I just need to know that you're answering my question. Okay, there's two more problems. If you wanted to try pausing the video and doing them on your own, that's fine. I'm just going to roll right through with them. So if you want to try this out, I would pause it, try it, and then we're going to go through it right after. So this problem here says the captain of a ship spots land. He is 40 meters above the sea, sighting land at an angle of depression of 78 degrees. How far to the nearest meter is the ship from land? So sticking with our approach to application problems, our what here is how far is the ship from land. And I'm circling the fact that we want to round to the nearest meter again. The bits of information that are interesting is that, well, we don't really care about this stuff that much. What we really care about is that the boat is, or the captain is 40 meters above the sea, and that we're sighting land at an angle of depression of 78 degrees. Now, from the previous problem, if you remember, angle of elevation was looking up towards the sun, so angle of depression would be looking down towards the ground. Okay, I like to think of it as just like depression in real life. If you're depressed, you look down, right? So we're going to draw our quick image. Here's our boat. Okay, here's the land that they spotted, and here's our captain. Now, the captain is looking towards land. Okay, we know him to be 40 meters right here. The angle of depression, which is him looking down, is 78 degrees. What we're trying to find is how far the ship is from land. Here's the ship, here's land. That's what we're trying to find. So now we have our plan drawn out. Now we need to think about solving it. So from our angle, we put theta. They gave us the adjacent side, and we're trying to find the opposite side. That means we've got to use tan. Tan of 78 degrees equals x over 40. To solve, we need to multiply by 40 on both sides, x equals 40 times tan of 78 degrees. And this is where your calculators come in. So we want to do 40 times tan of 78 degrees. And they tell us that that's 188.1. We want to round to the nearest whole meter, so that 1 tells the 188 to stay the same. We're talking about meters. So what we need to make sure we do is we need to make sure that we write our written response out. So we can say something nice and simple like the ship is 188 meters from land. Okay, nice, simple, easy, precise solution. We've got one more problem to check out. And here it is. Again, if you want to try this one out on your own, go for it. Pause the video, resume when you're ready to check. So, let's go through this problem. Central High School is planning to build a bridge across the road to PCTA. The road is exactly 48 feet wide, and the bridge must be tall enough for the buses, which are 11 feet tall, to pass under. What angle must the bridge make with the ground? Alright, well, I already drew a little picture for us, which sometimes they give us pictures to begin with. That's kind of cool. It's labeled as the road being 48 feet wide. We know that at the center it must be 11 feet tall. Okay. Now, what's nice about this is that we can see that really what we're working with here is two right triangles. Okay, so I'm going to redraw. So I'm working with just one. I'm only going to work with this one side. So here's my 90. I know that this has to be 11 feet tall because they already told us that here. What changes now, though, is that the length of this side is half of the original length, right? This side right here is up to this point. So we want it to be half of 48, which is 24. And what we're trying to find is theta. Now that we have our plan all set up, all we have to do is solve. So from theta, they give us the opposite and they give us the adjacent. That means that we're going to use tangent. Here it's tan inverse because we're finding an angle of 11 over 24. And we want to round to the nearest, let's say whole foot. It doesn't specify here, so let's round to the nearest whole foot. So we've got to type into the calculator tan inverse of 11 over 24. Round to the nearest whole would be 24.6. Rounding to the whole would be 25 degrees. So we need to make this angle at 25 degrees in order for us to pass the bus underneath. So again, we would have to write that down. The angle must be 25 degrees. And we have solved everything that they ask for. Alright guys, if you have any questions, bring them into class or post them on the website. I'll do what I can to answer them for you as soon as I can. See ya pretty soon.